Okay, welcome everyone. I hope you all had nice summers wherever you're joining us from. Welcome to this is the first seminar in our autumn or fall program of talks. We have a really fantastic lineup of speakers for you in the coming weeks. Before I introduce today's speaker, I'd like to take this opportunity just to advertise a new initiative we're trying out in the centre, which is we set up a website dedicated to financial stability, macroprudential policy issues. The idea in a nutshell is to have high-profile speakers write opinion pieces every couple of weeks on the site. The first article is by Paul Tucker, who is writing about shadow banking and the kind of the gaps in the regulation of shadow banking, with some ideas on how to fill those gaps. So I'll put the address for that website in the chat, so do check that out. Now, turning to today's talk, we've had a summer of headlines related to the impacts of climate change. So be it floods in Germany, extreme heat and wildfires in North America. And this is an issue that's, by my reading in the last 3 or 4 years, has really risen up in prominence for central banks in terms of the impact that climate risk is having on the financial system and the macroeconomy. We had the ECB put out their first climate stress test results earlier this month that many of you might have seen. So this is the topic of our first talk today. And I'm really delighted to welcome Ricardo Correa from the Federal Reserve Board in Washington, DC to present today. Ricardo is Deputy Associate Director of the International Finance Group at the board. He's a globally renowned expert in banking, financial stability, so I can't think of a better person to lead off our seminar series. So Ricardo, welcome. Very much looking forward to your talk. So for those of you who are new to our seminars in the audience, Ricardo will speak for something like 45 minutes, leaving time at the end for discussion. If you have any questions during the seminar, please post them in the Q&A box and I can relay those to Ricardo, but we'll have a broader discussion as well at the very end. Okay, I hope that all sounds good. So let me hand over to Ricardo. And over to you.
Thank you, David, for the very kind introduction and for inviting me to present at this a wonderful venue. So I'm going to present today some work that I have with Ehe, Christoph Herfer, and Orlel. And as David mentioned, I work at the Fed, so I have to give you the usual disclaimer. These are our views, and they do not necessarily represent the views of the Federal Reserve Board or the Federal Reserve System. Before I start, I want to apologize if my dog starts barking in the background. I'm still working from home, so we know that these things are difficult to control. So let me start with a little bit of motivation for our paper. So we all know that climate change is a material and consequential issue for the world. There are many estimates out there on the potential impact of climate change on the economy, and abstracting from other factors like social tensions and the health issues that may impact the population at large. So there are estimates out there, for example, that damage could be up to 10% of U.S. GDP by the end of the century. Moreover, recently the IPCC, the Intergovernmental Panel on Climate Change, has updated their estimates on the impact of climate on different physical factors. So, for example, they have become more certain in terms of the linkage between climate change and the frequency and intensity of severe weather events. And this is projected to continue going forward. and there are still a lot of uncertainties in terms of how the physical impact of climate change may evolve, and we may even hit nonlinear points where natural disasters may become really, really prominent and have a material and big impact on economic outcomes. So as we all know, David referenced the ECB stress test, but from some time ago, standard setting bodies and even central banks have started to try to assess how to incorporate climate into their own thinking about this issue from either a regulatory perspective, a financial stability perspective, and even a monetary policy perspective. So in last year, the Financial Stability Board started producing a series of documents on climate. They have been deeply involved on climate issues for some time, and for example, focusing on disclosure. But last year, they published a nice document. And in that document, they noted, for example, that the manifestation of physical risk, particularly those prompted by the acceleration in climate change and its economic effects, could lead to changes, for example, in asset prices and generate a lot of uncertainty. So there's some work that has started to link climate change to economic effects and then to financial stability effects. Which is important for those of us that are interested on financial stability topics. Moreover, as I mentioned before, depending on their own mandates, central banks have started to think how to incorporate those changes or those potential effects of climate into their own operations, and on their thinking from a policy perspective on how their own instruments may have to react to the potential impact of climate. So this is a citation from July 2021, where the ECB Governing Council noted that they will incorporate a climate change into their monetary policy framework, and they just finished the review of that framework, and they incorporated some of those issues there. So what's the link between climate and the financial system? And I think there's a lot of new work on this area, but there's still more to be done, especially if policymakers want to address climate change with some of their tools. I think on the research side, we still have to do more to outline these linkages between climate and the financial system or financial stability issues. So one of the critical problems with assessing the impact of climate change is that some of the larger effects are expected to be material in the longer term. So in 20, 30 years, when we think about a financial stability policy or regulatory policy or a monetary policy, we always think in the context of either the short term or the medium term. So these are things that we're not accustomed to dealing with. So one of the things that we have to do as researchers is start to think about ways in which we can measure the potential impact of climate change on outcomes of interest that have a short-term duration. So for example, in this paper, we're going to focus on loans, and loans are typically have a maturity between 5 and 7 years. I mean, some are shorter, way shorter than that. So the impact of climate or the big impact of climate is not going to be necessarily priced into this type of instrument. In a moment, I'll come back and tell you how we can avoid this problem. But let me just start by noting how the literature has addressed this issue. So a lot of the papers that have focused on the impact of climate I've tried to find assets that have longer durations. So some examples of those are equities, for example, for firms, or real estate assets that have a much longer duration than other financial instruments. And then they have tried to assess how climate in the future may be priced into those particular instruments. So a very nice example is a paper that has looked into municipal bonds that have a maturity of typically more than 10 years. And they have looked at, they have tried to assess how the rise in sea levels may be already priced into those instruments. And they do find some effect, especially in recent periods, where the pricing in those municipal bonds has started to react to this forecast about rising sea levels. So how are we going to deal with this problem of the temporal mismatch between the financial instrument and the impact on climate? So one of the channels we're going to focus on is the main channel that we're going to focus on is severe weather events. So as I noted earlier, the IPCC has noted that this severe weather events have already become more frequent, and they become stronger in recent years due to climate change. So in this paper, we're gonna take on that. We're gonna take that relationship as given, and we're gonna try to assess whether banks update their priors when they see this severe weather event happening, and whether they reprice the loans that they make conditional on those events, those severe weather events happening. So, and to do this in a rigorous way, we of course have to have a set of placebo events. So, or differentiate between different types of natural disasters. So we again go to the literature and try to find those disasters that are more closely associated with climate change. And we looked at different sources. I think the consensus is that hurricanes, floods, and wildfires are closely associated with climate change, while other natural disasters such as earthquakes and I think in a more clear way, winter weather are less closely associated with climate change. So we want to compare the impact or how banks react to these two different sets of disasters, how they react in terms of the pricing of the loans that they originate for different borrowers that have different levels of exposures to these types of natural disasters. So that's in a nutshell what we're trying to do. We're trying to disentangle or trying to identify how climate change is already being priced into loans through natural severe weather events that are associated with this change in the climate. We already see anecdotal evidence on how banks are trying to incorporate climate into their own calculations. So for example, we went to 10K filings. So these are disclosures that the banks made on a regular basis where they present their financial statements and other material information for investors. So we looked through them and try to find references to climate disasters, whether they reference climate disasters as a risk factor. As you can see from the first column there, and most of these banks in 2019, and these are the largest U.S. banks, were referencing climate disasters as one of as an important risk. They were also mentioning that there was a worsening trend in these climate disasters, And they cited specific disasters that are closely associated with the ones we mentioned before: flooding, wildfire, hurricanes, storms, heat, and so on and so forth. So the banks are aware that this is a problem, and that is a problem that could affect the creditworthiness of their borrowers. And we have a quote from PNC down there where they specifically note first the increase in the frequency of and severity of adverse weather conditions, and second, that this effects could affect the creditworthiness of their customers, or the value of the loans, of the assets that secure those loans. And this is not like a recent phenomenon. So if you go back in time a little bit, you go back to 2010, you would see that some of the banks in these filings were also reporting climate disasters as an important risk. Not all of them, as they're doing right now, but some of them, and they were already noting the worsening trend, and even some of them were flagging specific disasters. So this has evolved over time. I think probably in recent years, there has been more attention to this linkage between climate change and the severe weather events, but this is not a new issue. Financial institutions have also looked at this over time, and they potentially have incorporated this into their pricing decisions. So how are we going to identify this? And I think this is an important part of this exercise, is thinking through how we can identify the effect of climate change. So may I pause here? David, any questions from the audience?
I was going to ask you on myself, actually, just triggered by what the material you just presented, Ricardo. So could you say something about, do these financial firms, do they go beyond, flagging these as risks? Do they report, I don't know, the impact on capital or anything like that? Do they try and quantify these risks through stress tests at all? Or is it kind of still a step back from that? And anything you could tell us in that space would be interesting, I think.
Yeah, at this stage, I think this is still a stage where they're reporting this risk, but there's no like material action in terms of a capital or doing larger exercises like a stress test. There's some anecdotal evidence of loan officers noting how they look at these disasters and they try to incorporate those into their own risk modeling, but this is not done in a consistent way. I mean, there's not yet, and we gather this from surveys of financial institutions across different jurisdictions. There's still no systematic treatment of climate disasters into like risk management practices. I think some jurisdictions are more advanced in that regard, and for example, with the setup of stress tests in different locations. I think financial institutions have had to move very quickly in this direction, try to incorporate systematically what's the impact of climate into their own risk management practices. Again, I mean, there's still no concrete link between these disasters and capital, for example. And not even in the stress tests that have already been conducted. I think there's no expectation yet that banks should have additional capital to absorb climate. I think we're in the early days of this. I think we still have to know more about these relationships. And as I mentioned before in the introduction, things are going to get worse in the medium to long term. So I think the important thing is for the financial institutions to have this risk management capabilities and know how to incorporate these events into their own assessments of risk. And later on, when I think these natural disasters intensify, then we would have to think potentially about how to link this risk to the capital positions of the banks.
Yeah, very good. Thank you.
Thank you. Great question. So a critical thing in this type of studies is to identify what's coming from this expectation of the change of the intensity and frequency of these disasters that is driven by climate. So in this simple graph, you could think about a naive setup where you have a firm that is potentially going to be hit by, or it's going to be directly hit by a hurricane, and then in this setup we could explore what's the impact of this natural disaster, in this case this hurricane, on the pricing of loans originated by this bank to this firm A. The problem with this is that it confounds many factors. So if the firm is directly hit, there's going to be reconstruction in the area. That's going to affect the borrowers in some way. The bank is in the short run, there may be some negative effects, but if there's some reconstruction and some resources poured in to this process of fixing what the natural disaster created, we could observe even a boost in the medium term in terms of the activities of this particular firm. So instead of going this route and trying to assess the direct effect of natural disasters on particular firms and how the banks price the loans to this particular firms, we follow a slightly different approach. So we know, for example, in this case, that the firms in the Gulf area are exposed to hurricanes. So firm A is exposed to hurricanes. Firm B, who's located in Houston, is also exposed to this hurricane. We know that this hurricane is gonna directly hit firm A, which is located in New Orleans. So what we want to assess is how banks reprice the loans of firm B when the hurricane hits another location, in this case New Orleans, and affect another set of firms in that location. So we think that this at-risk firms, following this at-risk firms, is a way of capturing the expectations of the banks with regards to climate change and how climate change can affect the intensity and the frequency of this natural disasters. So this is the route we follow. Of course, there are other issues. So the bank could pull back from simultaneously from all its locations, so A, B, and potentially from other locations. So that's why it's important to control for what the bank is doing in aggregate. So in our identification strategy, we're gonna drop firm A, but we're gonna add firms like C, which are not directly affected by these natural disasters. And we're going to compare the outcomes of firm B to firm C. That allows us to control for overall supply side effects for the banks, from the banks, for example, by including fixed effects at the bank level and by period. So by focusing on this comparison between firm B and firm C, and dropping firm A's, we can directly measure what are these expectations, or what's this climate change component that is being priced into loan spreads originated by this by these banks to firms that are at risk of being hit by a natural disaster, but that they're not directly hit by those disasters. So a big part of the paper is working with data, and I don't know if in the audience folks are familiar with climate change analysis, but it's a very data intensive work. So in climate analysis, one important thing is looking at different layers. So one layer here, for example, is the layer of a geographical distribution of the firms. Where are they located geographically across in this case, across the United States? There's a second layer, which is which areas are more prone to natural disasters. So we have to combine these two layers to be able to do this type of analysis. So in the first layer, the geographical location of the firms, we use information from the National Establishment Time Series NET database collected by Dun and Bradstreet. And we use this information to know the specific geographical location of each firm in our database. And we're gonna focus on publicly traded firms because we need information from CompuStat to be able to get data for balance sheets and other financial information across these firms. So how do we classify these firms? We classify firms at risk. So this the firm B that you saw in the previous chart by looking at firms that have a geographical footprint that make them exposed or significantly exposed to natural disasters. So in this case, we look at exposures to disasters, and we look at and we flag the firms in the top quintile of that distribution. So these are the firms that are indirectly exposed to natural disasters. We conduct this separately for each type of a natural disaster. Now we combine this with information from the Sheldos database, which has this is a US database that has information on the cost of natural disasters at a very fine geographical breakdown. So it allows us to look at a county level costs related to natural disasters. We don't focus on all the natural disasters. We just focus on those where the governor declares that there's a state of emergency and they make a formal request to FEMA. So these are slightly larger disasters. So the database encompasses a wider set of disasters. We're focusing on those that are big enough so that the governor sets a state of emergency. And then within that population of disasters, we focus on those on the top decile of the distribution of each type of disaster. And to do this analysis, we focus on 10-year windows. So for example, we look at 1990 to 2000, and we see which counties were affected by, say, hurricanes. And then in that group of counties, we select the top decile, and those are the ones that are prone to natural disasters. So we combine this with the information from the firm, and that's how we create this category of firms that are at risk of being hit by or being faced by a particular set of natural disasters. We combine this with information from GeoScan. So that's the main source for loan information. So again, we're trying to assess the pricing, how banks change the pricing of loans for different firms when they are exposed to these natural disasters. And at the end of this process, we were able to have a sample of 21,262 loan facilities between 1996 and 2019. On top of that, One of the issues with this deal scan data, the syndicated loan data, is that we only have information at origination. So we know the pricing of these loans at origination and all the characteristics of these loans, but it's difficult to track them over time. So we're gonna do two exercises. First, we're gonna have information on a secondary pricing for the syndicated loans, and second, we're gonna use information from the FRY 14, which is sort of like the backbone of the stress test infrastructure that the Federal Reserve uses to conduct its own stress test. And from that data set, we know the internal probabilities of default that the banks assign to different borrowers. And this information is available on a quarterly basis, so we can follow a firm quarter by quarter, a firm bank relationship quarter by quarter, and we can see whether the bank changes the probability of default of that particular firm over time. So those are the sources that we're going to use in our setup. Here, very quickly, this is the information from Sheldon that I was mentioning in terms of the cost of the different hurricanes and the geographical distribution. So the number of counties that were affected. Once again, we're going to divide the sample of natural disasters between those that are more closely related with climate change, so hurricanes, wildfires, and flooding, and those that are not as closely related, earthquake and winter weather events. And as you can see, for example, in the case of hurricanes, a lot of the counties that get affected are in the Gulf region or the Atlantic coast. The distribution is somewhat different for winter weather events, where big snowstorms and cold weather happens mostly in the northern part of the U.S. The same thing happens with earthquakes and others. So we have like different geographical locations depending on the type of natural disaster that we explore. So what is our setup? So our setup is very simple. So on the left-hand side, we're going to have the spread chart on each loan at the origination. So spread by bank J to firm I at time T. The coefficient of interest is going to be this beta 1, which is the interaction term between whether a firm is indirectly exposed, in this case, to hurricane. So this is the classifier that's going to tell us whether a firm is a B firm in that graph that we had before, and whether we had a hurricane, an indicator that's going to tell us whether there was a hurricane in the last 3 months. So this is going to tell us, going back to the graph, whether this firm B was at the same time or was indirectly exposed to a hurricane at a particular point in time because that hurricane hit somewhere else. Crucially, as I mentioned before, we have to control for different factors. So we have borrower fixed effects, and importantly, as I mentioned earlier, we're going to include this bank year fixed effect, which allows us to compare these two firms, in this case, firm B and firm C in that chart at a given point in time. So that's the comparison we want to make, indirectly exposed to non-exposed at all at a given point in time. And then we include other loan and firm controls like loan type, maturity, covenant, firm size, profitability, and the debt ratio of the firms. Again, coefficient of interest is beta 1. And if beta 1 is positive, that means that these banks are charging a risk premium to this firm at this point in time, potentially because they are updating their expectation about the climate change and its impact on severe weather. So let's go to the results. Unless there are any questions here, I can start with the results.
I think you're good to carry on.
Perfect. So let me start with the results. This is the main set of results. So again, as I mentioned before, the coefficient of interest is beta 1. and we run different specifications depending on whether they have loan controls, firm controls, or both. What we find here, and it's nicely shaded in red, is that these firms that are indirectly exposed to hurricanes are priced between 17 and 19 basis points more around the time that a hurricane happens. So this is not a huge, but if you want to put it into context, this would be similar to the firm being downgraded between A and A minus at a given point in time. So that's it's equivalent to that effect on the spread that the firm is charged. So it's a material effect. It's not huge, but it becomes even more important when there's attention being paid to those events, I'll come to that in a second. So this is the first evidence I show you that at least banks are implicitly pricing the impact of climate change through severe weather events to these natural disasters. Of course, it could be that they just charge the same thing for any type of natural disaster. So we have to run a bunch of placebo tests. And as I mentioned before, our placebo tests are mainly by looking at other types of natural disasters. So for example, if we look at earthquakes and we define recent earthquake as an earthquake happening in the US, we don't find any relationship between firms that are being exposed to those earthquakes and the saliency of those earthquakes by some earthquake happenings somewhere in the US. There's no relationship to spreads in this setting. One question is there are not that many earthquakes in the US. So what we do is we looked at international earthquakes, big earthquakes that happen around the world, and see whether those earthquakes create this saliency about the importance of earthquakes. When we do that, we don't find any results either. When we look at winter weather, when we look at winter weather, we don't find those results either. But what about other severe weather events that are associated with climate? We do find similar results for fires. The effects are smaller, but are still there. So there's a positive relationship between the firms that are at risk and a recent wildfire happening in the recent past and spreads. And same thing for flooding. The results are smaller, but they're there. So let me go back to this question of saliency, which is quite important. David, any questions?
Yeah, can I convey one question? This is from my colleague, Tim Foreman, who asks, it's coming back to the hurricanes case. So he's asking, where hurricanes affect things like transport networks that then you'd expect to affect all firms in an area, does that kind of cause any issues for your identification strategy at all? Or how do you think about that sort of, the aggregate effect of events? There's your dog that you...
That's my dog. So he has an answer for you guys. So I think that's a crucial question. So one of the things that we focus is on suppliers and customers of the firm. So we look at supply networks. So it may be that I'm located in Houston, but my supplier, my customers are located in New Orleans and they're hit by the earthquake. So if the earthquake happens, is that a problem for me? So we look at that, we control for that. I'm going to show at the end some additional robustness that we do. We control for that and we find similar results. Similarly for banks, it may be that banks start to shuffle resources within their organization, and that's why some of these effects are happening. We try to control for that and the results don't disappear. I'll get back to that at the end, but we do a host of robustness checks because these are important issues.
Very good, thank you.
So we want to think a little bit about what's the economic channel, and one of the channels we thought about is attention. This hurricanes or this severe weather events happening at a given point in time may be associated with more press or more news related to climate, and that's how banks start to incorporate this information into their process. So if a hurricane happens in the Gulf area, and there are a lot of press reports about this hurricane and how those hurricanes are associated with climate, then that brings saliency to this topic, and that's going to have a bigger impact on the decision of the bank. And so we try to analyze this in several ways using different indexes. So the first one is an index computed by the Wall Street Journal, by Engel et al., based on information from the Wall Street Journal, where they look at the intensity of references to climate change in this publication. So what we do is we construct a triple interaction term with this index. So when there's a lot of talk about climate, this index goes up, and we want to see whether at those points in time the effects are stronger. And as you can see here by those coefficients highlighted in red, those triple interaction terms are quite significant and are much larger than the point estimates that I showed you earlier. So when there's more attention to climate, the pricing relationship with these natural disasters, when there's a firm at risk, is stronger. So this is one way of doing it. It's not directly looking at that association between climate and severe weather, but this is a way of doing it. We then look at more direct associations between climate and natural disasters. So this indexes here are searches, Google searches for climate change, terms related to climate change, and different natural disasters. So hurricanes, flood, fires, and winter weather. So when there's a search for hurricanes and climate change, this indicator is gonna show that. So as you can see, those searches have intensified in recent years, and when we use this other index, we do find a relationship between again a strong relationship between attention to these natural disasters and the relation to climate change and the pricing of loans. And yet a third one, so it may be that Google searches have issues. So what we do in this particular search is we go to the Reuters historical news archive. We go back to 1995, and we look at all articles that reference either hurricanes, tropical storms, so this type of cyclones. And in the same article, with some proximity, they also reference terms associated with climate change. So, for example, in the article, it may say hurricanes or the intensity of hurricanes has been associated with climate change. So that would be captured here, and we count all the articles that reference those two things together. As you can see, there's a big relationship in the 2005 to 2010 for two reasons. One, because there were a couple of big hurricanes around, because the AR4 by the IPCC was published, and in that report there was a lot of discussion about the association of natural disasters with climate change. And as you can see, in the last 10 years, there's constantly this relationship between the mentionings of hurricanes and climate change in these news articles. So we use also this index, and we also find some stronger relationship between the pricing of these loans and this mention of climate change. Now, as I mentioned earlier, one of the issues that we have is that we only have the pricing of origination. So what we do is we look at the secondary loan pricing information from Refinitiv's Loan Pricing Corporation. So we can, with this information, we can set up an event study and see what happens 12 weeks before and after a natural disaster happens. We have that we find that the economic magnitudes of our results are twice as large as for the primary market. Here, how you read the table is a little bit different. I mean, these are prices. So a decrease, what this is showing you is that the price of the loan goes down. So like with bonds, that means that the rate in theory goes up. So we do find that in secondary loan pricing data, the result is significant, and it's even stronger than in the primary market. In part, I mean, we haven't delved into this, but in part, this could be that there are different investors in the secondary market, and those investors may be more aware of climate change issues. The next exercise is looking at this internal probabilities of default by the banks, set by the banks. So as I mentioned earlier, this information is collected as part of the annual stress test. We use information between 2014 and 2019 because that's when the banks had to report these probabilities of default. And these are the results. So they're statistically significant, and they last for some quarters. So for example, in column 3, although the 3 rows have non-significant results, if you sum across the 3 quarters, you're gonna see at the bottom of the table that at the end of that period, you're gonna have a probabilities of default for a firm that is at risk. It's 1.4 percentage points, 1.4 percentage points larger. This may sound small, but this is about 1/4 of a standard deviation for the sample PDs. Again, this is a period of economic expansion, so average PDs were quite low. They were in the order of 5 percentage points. So this is a big change, and there's some persistence into this result. So we also look in the cross section. So we look at different at firms with different characteristics. So we find that the firms that are riskier are the ones that get a big bump in their risk premium. So firms that have that are levered, that have a low tangibility, or that are non-investment grade, they get a bigger bump in the pricing of their loans. We also looked at the different disasters depending on the magnitude or size of those disasters. We find that the results are stronger for bigger hurricanes. So those that have a big losses, more than 100 billion. So those bring more saliency into financial institutions. We don't find any anticipation effects. There's as you can see in the graph here, there's a pronounced spike in the quarter when the hurricane happened. This is for loan pricing information. So the effect happens in that quarter, and then it dies down a little bit. We do find sort of a different result for the PDs, which have a longer lasting effect, although the bump happens at the beginning as well. So one of the question is the initial reaction the correct one? So you increase the pricing of these loans at the beginning, and that's where the loans should be priced at going forward, or are these banks overreacting, or these loan officers overreacting because of saliency? And so that's what we want to test next. So if you have near misses, it could be that they're followed by actual hits, which means that which means that the initial reaction was the correct one, because you're increasing the risk premium because you know that in the future that may happen again. If we see that there are no direct firms hits on these firms that are at risk, so maybe the initial pricing was an overreaction driven by the saliency that we mentioned earlier. So what we do is we do this test where we look at those firms that are indirectly hit, so these firms that are at risk, and see whether they get hit later. And we do find a positive relation. So these firms that are located in Houston and that are at risk because they're in this location where they may be hit by hurricanes, they get hit at some point. So the initial, it may be that there's no initial mistake, that the initial reaction we thought was actually appropriate. As I mentioned earlier, we do a battery of tests to avoid to make sure that our results are not being driven by something else. So some are based on how we construct the data. So we have different ways of weighting where the firms are located. So again, firms that have a national footprint. So think about the Walmarts of the world. What we're doing right now is we're counting the Walmarts that are in different locations, but we can do the same with employment. So how much employment does a Walmart have in a particular place relative to another? So we do that type of experiment with this measure, and we find similar results. We can have alternative definitions for the treatment. So this is the threshold we set to determine that a firm is at risk. So we looked at the firms in the top quintile. We use the top quartile, and we find basically the same result. We exclude the financial crisis. We exclude hurricane season. So we exclude that period in the middle of the year when the big hurricane season happens, and we still find the results. We also use alternative attention measures. As I mentioned from that index that we constructed using Reuters data, there's a lot of attention paid to climate right after IPCC reports. So we look at the publication of those IPCC reports and the period after, and we find also strong results. We look at bank funding. As I mentioned earlier, we looked at customer supply length. So we do find similar results while controlling for customer disaster exposure or supplier disaster exposure. Because from the question earlier, I think that's a very important point. And we also try to find whether there are some real effects. So we looked at the CapEx investment by those firms, especially those that are non-investment grade and that are exposed to this hurricane, so to see whether the repricing of loans may have an effect. We do find some effect on that and on cash flow holdings. These are slightly weaker, but there appears to be some real effects, especially from segment of the population. So I think I'm almost out of time. So let me conclude by saying a few things. Based on our findings, it's clear that climate change is already shaping some economic risk today. This bank's statements on the awareness of link between climate change, as I mentioned earlier in the anecdotal evidence, between climate change, natural disasters, and loan risk. What we find is that there's a sharp and short-lived spike in loan prices in primary and secondary market after this climate change disaster. and there's no effect that we could find for other types of disasters. So this points to the fact that these banks may be pricing this climate effect on this severe weather event. The learning effect seems short-lived, although we also find from the internal probabilities of default that they could persist even for 3 quarters, and the change in probabilities of default seems to be persistent and material. So in conclusion, I think we provided the first study to directly link climate change to present-day corporate loan costs, which is very tricky because the duration of the loans is very short. It's 5 to 7 years, and the big effects on climate are going to come later. But this is sort of an appetizer to what could happen later if banks are to price these loans in a more systematic way, incorporating climate factors. So thank you very much, and I'm happy to answer any questions.
Well, thank you very much. Well, let's go right into the questions. So there are some in the Q&A box, which I can relay to you. So one, start with by Carlos Canyon, asks, I guess about kind of transition risks. You focused on physical risks here. Have you also thought about ways of capturing transition risk into this type of analysis? I'll throw another one to you as well, so you can answer them at the same time. So another one by Wenbin Wu. I was wondering this as well, actually. So I think when you spoke, I heard you talk about winter weather as you seem to classify that as something distinct from driven by climate change. So how do you think about that? Why is that a different risk to hurricanes? Maybe those two to start with.
Fantastic. So on the first question by Carlos, I think transition risks are quite important, and they may have probably even a more immediate impact on some of these decisions. The problem with the transition risks is that there are a couple of problems. One is that we don't have good disclosures yet in terms of, for example, if we're thinking about carbon pricing and things like that, at the firm level, we still don't have an excellent system to capture what are the carbon intensity of particular firms. So that's what a whole infrastructure is looking right now, to try to assess whether we have consistent disclosures across firms around the world, because now a lot of this is done on a voluntary basis. So it's very difficult to capture this effect with those data, because there could be a lot of sample selection. I have some colleagues that have an excellent paper that looks at some results from California. I think they try to change some regulations in California, and they're trying to price or try to assess what's the impact of those changes in those regulations on financial risk. So this is Ivan Ivanov and the others. I can send you the reference later, but I think that there are papers that are starting to find clever ways in terms of how to identify this. But again, I think the disclosures that are needed to produce solid work in this area are still lacking. On winter weather, this is an area that's murky. I mean, if you read some of the IPCC reports, by winter weather we mean snowstorms and things like that. They don't flag this as being as closely related to climate change as the other weather events that we noted in our paper. But this is sort of like in the murky area, because some have noted that there could be a relationship there as well. So that's why we put it there, but our focus is mostly on earthquakes when we try to assess our placebo event. So yeah. Okay,
let me give you a final one, so because I think this is a good question too. So this is again by Tim Foreman, who's asking about the way he puts it is cross-hazard effects. So do you get this effect where a hurricane kind of isn't just increasing the perceived probability of future hurricanes, but future climate events more generally. So is it like a climate factor that's being updated in beliefs? What's your response to that?
So here we have a result where we combine all the recent disasters, and as you can see, there's a strong effect there. So it's a combination of all these disasters together. So this could be like sort of like the climate factor that Tom is mentioning. So and we don't find this for the other earthquakes and winter weather. So there could be a climate disaster underlying this. I don't know if that answers the questions or if that's a specific question that Tom was referring to.
I think it does. Very good. Okay. You've got a busy day of meetings, I know, to go to. Probably draw it to a close here. Ricardo, thanks for a really fascinating talk. I think it's a brilliant start to our seminar program. You can see the paper on the website, so I'm sure you'd welcome future comments as well. So thank you very much and keep in touch.
Thank you so much for all the questions, all the comments. It was great having this presentation here. Thank you.
All right, very good. Bye-bye.
Bye.